Day 31 Notes, Advanced Algebra 2. The final type of trinomial that we investigate this week that needs to be factored are what we call non-standard trinomials. So non-standard trinomial is again going to be in the form of a regular trinomial, ax squared plus bx plus c, only this time we're going to say that a is not equal to 1. So any example where a is not equal to 1. Now here's an example of one. We have, let's say, 6x squared plus 5x minus 6. This is our example number 1. Based on the work we did yesterday and the day before, we might look at this and try to find a greatest common factor. Because if we can factor out, say, a 6 here, that would reduce this trinomial into a standard trinomial that can be factored using any one of our methods from earlier this week. However, we run into a problem because there is no greatest common factor for each of these three terms. It's already in its most basic and reduced form. So we have to try something different. And the method that we use for any non-standard trinomial that doesn't have a GCF is what we call split the middle. And that gets its name from this guy right here, the middle term of our trinomial. What we're looking for are two numbers whose product is equal to the product of these outer terms, which happens to be a negative 36x squared. And the sum has to match this middle term here. So the product is the same product as these outer two first and last terms, and the sum has to be this inner term, this middle term. So again, the product on the outside is 36x squared. That's a negative 36x squared. The middle term is a 5x. And what I need to come up with are two numbers, and I'll place them on either side of this x here, but two numbers that multiply together to equal negative 36x squared, but add together to make 5x. The pair that happens to work for this is both a 9x and a negative 4x. To discover these numbers, you have to use just mental math here. I don't expect you to list your factors out individually. At this point, we should be able to do this in our head. We should be able to find two numbers that multiply together to equal negative 36x squared, but add to make 5x. Again, that happens to be 9x and negative 4x. With those values identified, then I'm going to rewrite this original problem using these two terms to replace or split the middle term that we had at the beginning. So I'm going to call this now 6x squared plus 9x minus 4x minus 6. What we have here now is a four-term polynomial in which we can factor using the grouping method that we discussed yesterday. From here, in this first group, I'm looking for the greatest common factor of 6x squared and positive 9x. That happens to be a 3x. And after factoring out 3x from those two, I'm left with a 2x and a positive 3. For our second term, the largest number that divides both 4x and 6 is the number 2. And I'm going to call that a negative 2 this time to change our signs. We're going to go with 2x left on the inside along with a positive 3. That's what would be left after I factor out a negative 2 from each of these terms. Since these two terms inside the parentheses match, we know that that's going to be part of our final answer, 2x plus 3. And the final piece comes from the coefficients in front of each of those terms, 3x and minus 2. And here we have a factor pair of binomials whose product equals the original. We can double check that by foiling. 2x times 3x is 6x squared. 2x times negative 2 is negative 4x. 3 times 3x is positive 9x. 3 times negative 2 is negative 6. When these two middle terms combine together, since they're like terms, we have 6x squared plus 5x minus 6, which again matches the original problem that we had. Again, this is split the middle. We're splitting that middle term by using this x method to show our work. Let me write down another example for us to practice here. Here's another example of a non-standard trinomial, but in this case, again, we do not have a greatest common factor. So we have to use the split the middle method in order to find the correct binomial pairs that will multiply to equal this trinomial. Again, the technique that I recommend and that we show here at Butler Tech is called split the middle, and we start by multiplying these outer two values, the first and the last term in this trinomial. 3x squared times 8 is 24x squared. For the inside value, we'll reuse 14x. And what I'm looking for are two numbers that multiply, or whose product is 24x squared. So the product is 24x squared, and the sum is 14x. Two integers that multiply to equal 24x squared, but add to equal 14x. That happens to be 12x and 2x. So having identified the two values that multiply to equal 24x squared, but add to equal 14x, we can use them to split this middle term apart into two new terms. So the math that I'll show here then becomes 3x squared plus 12x plus 2x plus 8. Again, we just split this middle term apart into these two terms that we just identified by using our x. Then we use the factor by grouping method. We'll group these first two terms together and the last two terms together. Start looking for the GCF for each. The greatest common factor of 3x squared and 12x happens to be 3x. And after I factor the 3x from each, I'm left with an x and a plus 4. Then, after I factor the GCF of 2x and positive 8, I'm left with a 2 times x plus 4. This is a good sign for us because the x plus 4's match. I know that x plus 4 is part of our final answer. And for the final binomial, those pieces come from the coefficients that are left here, 3x and a positive 2. We have a factored trinomial, which now looks like a pair of two binomials. Let's do another example. Here's an example where we have a non-standard trinomial that has no GCF. So in order to factor it, let's set up the x here. We're looking for a product, a pair of integers whose product is equal to negative 18x squared. The product comes from these outer two numbers multiplied together. And the sum has to match this middle term. The sum has to be negative 3x. And the two numbers that multiply together to equal negative 18x squared, but add together to make negative 3x, happen to be negative 6x and positive 3x. Using those two values, we will split this middle term into those two values and then factor by grouping. So again, our original trinomial could be written as 2x squared minus 6x plus 3x minus 9. Again, since negative 6x and positive 3x can combine to make this negative 3x there, in the original problem, it's okay rewriting it this way. They're mathematically equivalent. Now, we'll group the first two and the last two terms together and find the greatest common factor for each. Greatest common factor of 2x squared and a negative 6x is going to be a 2x. And will be left behind, or what would be left behind, is the x and a negative 3. And in this grouping, the greatest common factor between 3x and negative 9 is 3. And left behind there would be an x minus 3 as well. It's a good sign for us to have the x minus 3 common, because that tells us that it's part of our final answer, x minus 3. And for the final binomial, we look at the two coefficients that were left behind, 2x and a positive 3. This would be the pair of binomials that factor out of the trinomial 2x squared minus 3x minus 9. Tomorrow in class, I'll have a practice worksheet for us to work on these, and then for Thursday, we'll start our big review to prepare for Friday's quiz.